So welcome everybody to our STEM series. Here with us, we have Jacob Torres. He is an Española native, and he is going to talk to you guys all about space biology and a really exciting initiative that he has that he's been working with. So I won't take away his story, but just want to welcome you, Jacob, thank you for joining us, and all the way from Kennedy Space Center. So I know you have a pretty busy day today, so just thankful for you to be on with us.
Well, I'm absolutely honored to be here. Thank you so much for inviting me, and especially I can see green chili in the background there, and so I feel like I am at home all of a sudden. So it's especially fun to talk to a group from New Mexico, and I'm so excited. How much time do I have to talk?
Just a little bit before 5. So I do try to cut off at about 5. So about 4:55. So 50 minutes.
Okay, cool. Awesome. So is it a good time to start?
Yes, go on ahead. The show is yours.
Okay, cool. Well, hello, everybody. My name is Jacob Torres. I am from Española, New Mexico. I was born in Santa Fe. I started, of course, I guess I should just start that I went to school in Española. My mom was a school teacher there. She was my first grade teacher when I started at Fairview Elementary. And then I worked up through school with my mom, who was in the school system. But the truth is that I wasn't a great student, at least at that age and at that time. There's a lot of thoughts about why that was. But I was a student at the time who just barely graduated high school. I wasn't great at math. I wasn't really top of the class or anything like that. But I was always good at building things and great at taking the initiative, and I loved to work. And so when I graduated high school, I said, forget, I don't need to go to college. I can just go out and get a job and I'll be fine. So for one of my senior years, on my senior year trip, we went to Las Vegas, Nevada. I play music, guitar, and at the time, the Hard Rock Cafe was like so super cool and awesome. And I thought that I would move to Las Vegas and get a job at the Hard Rock Cafe, and that's what I did. I started bussing tables, cleaning floors and cleaning the bathrooms and things like that, working for tips, and it went really good. It wasn't long before I moved my way up into management. And by the time I was 20 years old, I was managing the Hard Rock Cafe in Las Vegas. While I was working there, of course, there's a lot of famous people who go to Las Vegas and to the Hard Rock Cafe. And one night, the actor Bill Murray went in, and he was going to open his own restaurants called the Murray Brothers Caddy Shack. He saw me in action and asked me to go work with him. So I worked with Bill Murray here on the East Coast, opening restaurants in Myrtle Beach, South Carolina, St. Augustine, Florida, and Orlando. And I spent the first part out of school and the early part of my 20s working, and I did a lot of great work. I think it was a really cool career, but I always felt that I was able to do more. Like in my mind, I was running the restaurant and was doing a lot of good work, but I always felt like, gosh, I could do more. There's more things that I could do. But without an education, I kind of ran into a roadblock of things that I was qualified for. So after working in the industry, I eventually realized that if I wanted to move beyond managing the restaurant and those types of things, that going back to school, going to college was going to be the way to go. So at 27 years old, I quit my job, left Bill Murray and left Las Vegas and moved back home with my mom and moved into the room that I was in high school and signed up for classes at Northern New Mexico College, which is the community college in Española. And I started to go to school, initially my interests were to fix the cars that kept breaking down. I had cars and it would cost a lot of money to repair them. And it was like, gosh, if I could do that myself, we can save a lot of money. So I started by taking automotive technology classes there in Española, and they went pretty good. My professor, Gil Sena, was like, Jacob, you're doing really good. Why don't you try taking a math class or an English class? And You know, in my mind, I can't do that. I remember from high school, I wasn't good at math at all or anything, but eventually I took their advice and I signed up for a math class. And it turned out that when I showed up to that math class, there was a gentleman who was outside there who seemed really cool. And I go, oh, great. Hope maybe this guy will sit next to me. We'll be friends in this class. And the class started, he showed up to the front of the class, and it turns out that he was the teacher. And in the end, it turned out that this math teacher spoke the same language that I did, and we got along really well. And he put algebra and exponents and variables and all of these things in a way where I understood it. And all of a sudden, I started to do well in school. I did a two-year degrees at Northern New Mexico College. I thought that would be it. I'll, find a career from there. But when I finished, New Mexico State University sent a letter to me. They said, hey, Jacob, if you come here to finish your 4-year degree, we'll give you a full scholarship. And I was like, wow, well, gosh, I've always wanted to be an engineer. And I would always tell my mom, I'm going to be an engineer. But, I hadn't really acted on it. And so when the scholarship to go to New Mexico State came about, I was like, sure, I'll do that. So after graduating Northern, I went to New Mexico State University in Las Cruces, majored in mechanical engineering, and that's where I got my bachelor's degree. In 2014, there was a company called Cummins Inc., who are diesel engine manufacturers. They're one of the largest diesel engine manufacturers in the United States or in the world. And they were working on a 2017 diesel engine for semi trucks, which is a pretty big 12 to 15 liter engine. At the time, there were going to be new EPA standards, and every engine in the United States have to meet these emission standards. So I got to work on developing the cleanest diesel engine of its time in 2017, the ISX 15 liter. And it was all cool and fun, but I don't know if anybody will believe me when I say that an engine is an engine. And after a couple years, I actually got bored with it, and again, I found myself in the place where I was when I first started school. I reached out my qualifications, and to advance, I would have to go to do graduate school. So moved to Indiana to work at Cummins. I became a resident there, and it turns out that there's these great universities in Indiana. In particular, one is Purdue University, and I've always known of Purdue University. There's a lot of amazing people who went to school there, like Neil Armstrong, Buzz Aldrin, Drew Brees, and I was like, gosh, if I could go to Purdue, that would be great. So a lot of people said you probably won't get into that school, Jacob, but I did the GRE exam, and I did one application, which was to Purdue University. If I got in, I got in. If I didn't, I was going to go do something else. And sure enough, I got accepted there into the mechanical engineering program for my master's degree, and also got a teaching assistantship, which means that I would help the professor teach his classes. And in return, they would pay for tuition and fees and that stuff. So that was super cool. I got to work on this thing called the Biowall, which is a botanical air filter. It uses plants like these, like almost exactly these plants right here. And we found that they filter air. It was actually old NASA research that found out that plants like these can filter air and contaminants out of air. So we built a system that was a botanical air filter and put it into a house. And I wrote my thesis on it, and it was totally awesome. It was really cool. I always had this aspiration to work for NASA. When I was really young at Fairview and Espanola, we sat down to watch the Space Shuttle Challenger launch. And just that day, it was very unique, but the Challenger exploded in front of everybody. So we were these, little kids. I was in first grade, and the rocket that had launched blew up in front of us. The teachers had to, tell us about it, explain to us what happened. And it was so profound. I say that it was the 9/11 for us. It was our 9/11 when the Space Shuttle Challenger blew up. And when the teachers, my mom, who was the teacher, was trying to explain it, I just remember thinking in my mind that I always wanted to do something to make sure that that never happened again. And I always kind of remembered that. So fast forward to Purdue, and I'm thinking about what am I going to do with my career after I finish Purdue? And gosh, I always wanted to work for NASA. NASA would be like so cool, but it's really hard to get in. And I realized that the best way to get into NASA is to use your student status to get an internship or something like that, and then do really good in that internship, and then hopefully find a good job. So that was kind of my plan. I literally Googled NASA internships. This website came up. I think it's nasa.force.gov, and there was an application there to apply for interns. You can apply for 15 opportunities in one shot. My thing was JPL. They build the robots like the Curiosity rover and the probes that go out into space. And I was like, oh, I really would love to work on that. But in the application, there was one line that said, plant growth for food production in microgravity. And I was, oh, that sounds kind of cool. I was doing the Biowall work and I was using technology to grow plants. I got, maybe I have a shot at that. Well, guess who the only ones who called me was the plant growth team who are at Kennedy Space Center. And we got to talking, and it turns out that they're growing crops. They want to grow crops. NASA's mission ultimately is to go to Mars and go back to the moon. And along the way, the astronauts only have the food that NASA packs for them, which are freeze-dried meals. You take them out, put them in the microwave, and you eat them. But could you imagine going months or even years with just eating freeze packaged meal? There's nutrients and vitamins that degrade over time, and you lose that. And then also there's science that says that fresh food is a vital part of keeping a human body healthy over a long duration. So NASA has a problem where we needed to find a way to supplement nutrients as well as provide fresh food for astronauts to eat. And what came about was growing plants. They were growing plants in controlled environments, which, controlled environments means artificial lighting. They have like a refrigerator type, which controls the humidity, temperature, irrigation, and all of those things. And my Biowall was doing the same thing. The Biowall controlled the lights, it controlled irrigation, it recorded temperature, humidity, and all this stuff. Except instead of filtering plants or filtering air, they were growing crops. And so ultimately I got an invitation. Jacob, come over to Kennedy Space Center here in Florida. We'll give you 10 weeks. You can work with us. One thing that we're working on is learning how to water plants in space. Water acts very differently in space when there isn't gravity. And so we need people like you to work on that problem. So going with my plan, I said, I'm going to do the best job I can in these 10 weeks. And I did. I worked so hard. It went so well. At the end of the 10 weeks, NASA said, Jacob, you did great. Would you like to stay for another semester? I said, sure. So I did a second semester. The second one was 16 weeks. That went really well. And then when that one ended, a full job or a full-time opportunity came up, and they said, if you apply for it, we would really consider you for the position. So I applied for that position, and ultimately I got that full-time position. I'm a contracted scientist for NASA, and essentially I'm still being Jacob the intern, where I build things, whatever it is needed. We're growing all types of crops in space that have never been grown before, and they need hardware and equipment that doesn't exist. It has to be built. Somebody has to build it. And I just so happen to have this engineering degree that allows me to do it. So it's been really fun, and just this amazing journey. I got to join this team at Kennedy Space Center while they're launching the rockets and all the SpaceX rockets that you see. We are growing plants in the background, and it's just like super amazing. So along the way, we have two systems on the International Space Station. One of them is called Veggie. Veggie is a very simple system. It's a light with a bag around it, and you can grow maybe 6 plants inside. It's very small. And then the second one is the advanced plant habitat. And it's the opposite of veggie, where instead of very simple, it's more complicated. It uses automation to control the lights and irrigation. It records trend data. We can control it from here at Kennedy Space Center. And then that way, the astronauts don't have to do all of the work. We can do a lot of it from here, and then they go in and check in and harvest and do all those things. But until I had arrived, the team had done a lot of grow outs of many plants in space. In particular, we did things like lettuce or things that didn't require pollination. So leafy greens, Mizuna mustard, there's pak choi, all types of different lettuces. And these were plants that we would grow over a 28-day period. The astronaut can come in and inject water and keep them watered and everything. But an astronaut or a person couldn't live on lettuce alone. We would, if in order to fulfill our mission to supplement an astronaut diet, we would have to do like a variety of crops. And that means doing flowering crops, things that require pollination, and fruits and vegetables, and then maybe later on, and then maybe later on like processed food like rice, flour, and other things. But what plant do you grow for your first flowering plant? Which one is a good bet to send up to the space station and will grow? A lot of them require a transfer of pollen from one flower to another. And we don't have bees in space. It's hard to get crew time for an astronaut to go and transfer that pollen back and forth. And the thought came about that peppers are a good plant. They're not self-pollinating, but they have a flower where you tap it and the pollen pollinates itself in a way. So the male and the female part of the flower is in one spot, so an astronaut can tap it or shake the flower, and then that would pollinate it, and ultimately that would lead to fruit. And of course, the New Mexican in the room, you guys are talking about peppers. Well, hey, where I'm from, we love peppers. Actually, our state question is red or green because we love chili. And we eat them green and we eat them red. We have our own types of peppers, and by the way, there's a New Mexico Chili Pepper Institute at NMSU, and we had this great discussion. So I have a teammate. Her name is Lachelle Spencer. She's the lead horticulturist at Kennedy Space Center, and she ordered some New Mexico chili seeds and threw them into the crop selection list. We grew maybe 40 or more different types of varieties of peppers in these controlled environments. We simulate the space station, which means it's high CO2 because there's so many people that are on the space station. And it turns out that, more than half of the peppers don't like high CO2 at all. Most of them didn't even get to flowering, let alone fruit. But the New Mexico ones, they didn't care. They grew great. They didn't care that they weren't using the sun. They didn't mind the controlled environment. We were worried that they would grow too big, but in the end, they figured out how to fit within the space that was available for them. And it was so cool. But there was one problem, was that they took a really long time to grow. So, time and energy is really important when you're growing crops. And if you spend 80 days adding light, water, and work with nothing to eat, it's kind of like, it's a lot of wasted time. So we needed to find a pepper that would grow faster. We were growing the Hatch Big Jim, and the Big Jim grew great, but it took about 150 days before we got red peppers and to the final harvest. If we could find something that would mature a little bit quicker, even if it was 20 days or something like that, then that would have been great for us. And I just remembered, I'm from New Mexico. I went to, from Española, which is a higher elevation. And then I went to NMSU, which is down by Hatch, which is at a lower elevation. And I knew that winter comes sooner in the northern part of the state because we're up in the mountains than it does down south. And a pepper variety from up north will have to mature quicker, or you would never have peppers. So we put out an order for some more varieties, and one of them happened to be the Española Improved, which was a hybrid pepper of the Sandia pepper and the Española traditional pepper. And we grew that in there, and my goodness, it cut 20 days off of the grow period, which meant less energy, less work. And then these peppers just grew great. So in the end, for PH04, the team grew a pepper with my hometown's name on it, but it was from New Mexico. And New Mexico chili is the first fruit grown in space. And it's been so exciting. But so that's kind of my story and what has come out of it. And I'm sorry, my computer is being weird, so I'm gonna have to show you the screen of my computer. I hope you guys don't mind. But while I was working at Kennedy Space Center on the peppers, I thought that it was cruel that I was the only New Mexican who got to see all of the pepper growth that was going on. And I really, more than anything, wanted to find a way to get everybody at home involved, but especially at home, but also, you know, anybody who wants to participate in Space Chile or growing peppers. And what came out was this activity that I started on my own called the Space Chile Grow Pepper Plant Challenge. I would work on it during my free time at night. It was a thing that I mentioned to my team at NASA, and maybe they didn't all understand what I was trying to do. And they were like, that's really cool, Jacob, but they weren't really looking to help me at that time. So I went on my own. I didn't have funding. Facebook is free, so you can start a group for free on Facebook. So I started this Facebook group page, wrote an introduction, and there's an introduction here, and it kind of goes through what the mission is and what we're doing and some issues that I'm seeing. And you are all New Mexicans, so you will definitely know that. And I'll be the first one to say that our peppers, our chili doesn't taste the same unless it's grown in our dirt and in our soil. We can grow it in other places, and sure, it's still an Española pepper, it's still a hatch pepper, but I know that green chili doesn't taste as good as it did when I grew it, you know, down in Las Cruces and stuff like that. But for this mission to be successful, I'm going to have to figure out how to make them taste good, and I'm going to have to figure out how to grow them well. And one of them was, we were joking that it was like a pepper roulette. You know, you would eat one pepper and it would be hot, then you'd eat the next pepper and it wasn't hot at all. And so it was this weird problem that I didn't know what was going on. And I said, here's an opportunity for me to create an activity, invite other people to join in, and then help me to learn how to grow the peppers hot. And that was what originally started this challenge. Was I challenged everybody to grow the hottest pepper, and then you grow the pepper that I send to you, send one sample to UNM, and then Dr. Hansen over there does capsaicin analysis on it to see which one is the hottest one, kind of thing. And it turned into this amazing project where, of course, COVID had just happened. I had this, you know, free activity that anybody can join at any time in my lap. It could be done at home while you're teleworking or while you're in isolation. It can be done in your classroom or at work. The only rule, really, the only two rules is that one, you get the seeds from me, and then two, you grow your pepper plant indoors or in a controlled environment, and then figure out what has to be done to grow that. And so it turned into this crazy, awesome activity. There were people joined from around the world. And just recently, what was a bootleg experiment that really NASA didn't want anything to do with, it gained so much popularity that recently NASA funded it. And actually, this is one of the first presentations or discussions that I've had since I've been funded with NASA. So you're one of the first groups that I've talked to as a NASA funded program. And of course, my computer isn't working today. So we're going to have to start it out pretty hard. But so essentially, normally I would make a presentation and make some slides and share it with you. The only thing about that is that the second I make the slides, they become outdated, and then something new happens. And then I'm like, oh, I missed it, or I won't be able to present it. So what I'm gonna do is just show you some stuff directly from the Space Chile Grow Pepper Plant Challenge page, and show you just, what my little world is like and what's going on. So I'm just gonna scroll through some posts and talk through it. The first one is, I just found this one today. We have another one of my fellow interns who also got hired too. Her name is Jess Bunchek, and there's a facility called Eden ISS, which is in Antarctica, and it's the closest we can get to growing in space, but here on Earth. And when Jess went down there, she wanted to grow some peppers. So in her bag,
Jacob,
I put in, yes.
This is Anita. I don't know if it would help you at all, but I actually have it up on my screen. Would you like me to share my screen so you can just talk and not have to worry about filming both? Or are you okay
Sure.
to do it your way? Whatever your preference is. Sorry to interrupt you.
It's okay. I can just keep going because I'm just kind of going fluid about it if you like. But
no, that's fine. I just didn't know if it was difficult to have you filming the way that you were doing, or if you were good with it. So
it's okay with me if it's okay with you.
Perfect. Keep going. Continue.
Okay, cool. So anyway, Jess Bunchek is down in Antarctica, and this came out in her post, and she's growing Española, Española chilies, and then that's Chimayo chilies right there. And it's super exciting. But through this activity that I started during my free time, part of them, some seeds found their way down to Antarctica where Jess is growing them. And she put out a Christmas post where she decorated her tree with nothing but New Mexico chilies, which is just like so cool. It's just so awesome. This is a group that I visited today, and I had computer issues with them as well. But they're a third grade group that are in Oklahoma City, and they grew peppers enough to make a ristra. So like Oklahoma City, a group of third graders, and they're making ristras. It's just like, oh my gosh, I think it's like the coolest thing in the world. And so I had to jump in on a computer, on a Zoom call with them to congratulate them. And I'm just so excited to see other people than just New Mexicans getting into chili and what we do. This is Steve Arthur. And Steve Arthur is in Kansas. He's a librarian at the library there, and he's taking on the Space Chile Grow Pepper Plant Challenge. Our thing is that everything that we grow in space has to be launched up there. And so everything, if it has to be launched, then it costs money, and you want to grow in as minimal amount of growth media and resources as you can. So we've been growing in these little cups. And the reason we've been growing in these cups is because it's a small amount of dirt. And the challenge that he's been taking on is to see if he can grow peppers, how small or how little amount of soil can he grow peppers in. And that's what he's been working on here. And so he's showing some really pretty fruit. Then he grows them out, records and documents some data for me, like just the basic things like when did it germinate? What day after plant did they start to flower? When did he start to see fruit? When did he have green chili? When did he have red chili? And then in the end, he'll record how much fruit he harvested. Did he, what was the total weight? And then other things that he noticed. Then he'll send that to me. I'll add it into a database. And in the end, my hope is that this will turn into a database. And when we go to the moon, which will be very soon, I'll have this database in hand to be able to show NASA, hey, look, these peppers grow well in controlled environments. Here are all the examples that we have. I think New Mexico chili should be the first fruit grown on the moon as well. And that's kind of what we're working towards right now. We did PH04 and we grew the first plant in space. And now I would like to grow the first pepper on the moon. And so moon chili, I think would be totally cool. Javier is another teacher. He's from Colombia. Getting the seeds to Colombia was super, super hard, but we finally got them there. And what he's doing is he's showing, that he's growing inside a refrigerator, which I mentioned that the APH is like an old refrigerator. He turned his into a growth chamber. And then these are just all the germination that he's doing. So he'll grow those seeds and then record a germination rate for me. How many out of the 2, 4, 6, 8 seeds grew? And then, that he'll turn that into a percentage and then report it to me that I can document that as the germination rate for these pepper seeds. And that's important for everybody else, because if you know the germination rate, but you're not seeing your growth, then that you have a problem, kind of thing. In my lab at Greenworks, I'm also growing peppers too. I'm growing Española improved. And so this is a post from me. In this case, I didn't want to start over. If you start over, that's another 80 days that you're waiting for fresh peppers to grow. But what I didn't know, because I'm from New Mexico, usually we harvest our peppers when winter comes, and then we start over when the new season comes. But it wasn't until I got to Florida where I learned that our peppers are only starting to grow when the winter comes. That if you let them continue to grow, they will continue to put peppers out, and you'll have something fresh to eat. I have fresh peppers to eat almost every day. And then I save these seeds, and these seeds become part of the experiment. And then people who reach out to me to get seeds, I put them in a pack and then I send them out to you so you can grow them too. And so this is really cool. But one thing I didn't know until I moved to Florida was that our New Mexico chili grows well beyond winter. And these ones are 8 months old and they're going strong. And so that's a really cool thing, which means I don't have to start over. Mitch is from Albuquerque. He is an expert New Mexico chili grower, and he lends his help to the Space Chile Challenge. He's also growing in the cups, and he's trying to grow in as small amount of media as he can, and then he documents it for us. And he was actually on the Santa Fe New Mexican with his grow out. One cool thing about being a scientist at Kennedy Space Center is that you get to watch the launches. And SpaceX is launching, rockets all the time, as is NASA and all types of other things. And I try to share that experience with everybody so everybody can see it. And so hopefully my computer, it's not going to do it. Error unsupported. But everybody can go on to the Space Chile Grow Pepper Plant Challenge group page. And on here is the first launch of the year. I was 2 miles away. And it was just like the coolest. So this is a really cool video. You'll have to take my word for it, I guess. But, as I'm growing plants and doing my thing, I get to stop every once in a while and enjoy all the amazing things that are going on around me, which includes talking to astronauts sometimes and meeting, amazing NASA scientists and all that type of stuff. And I use this activity as a way to get you involved so you can see it and you can be here too and you can check it out. So I put this post out about an hour before. Who wants to watch the first launch with me? Stay tuned, and then I'll go live showing the video and stuff. And I apologize that I couldn't show that to everybody. This is Mitch, who's getting ready for his grow out. And essentially he's just trying to grow as many pepper plants as he can. And then he's documenting how they grow along the way. When do they start growing? When do they flower? When do they fruit? All of those things. That data will turn into a profile that I can make. And then, like I said, one day I hope to be holding that profile when they're looking for plants to grow on the moon. And I just would really, really love to see these pepper plants become the first plant grown on the moon. So one thing about growing in controlled environments is you're reliant on technology. And it is known for technology to fail. Right now I'm holding my cell phone. Well, I'm showing you my computer screen. It's because I couldn't get my computer to work. The same thing happens with irrigation all the time. We use automatic irrigation to keep the plants growing. And then the pump fails, or the computer crashes, or something happens. And in general, if you're growing something like lettuce or leafy green and you go a day or two without adding water, your experiment's over. And we're very used to that. We're used to completely losing our experiment in the science, and it's just a bummer. It really is. But if you grow New Mexico chilies, this one here, I went on vacation. I went home to New Mexico. I stayed with my mom the whole time I was gone. We didn't add no agua for 10 days. Will they grow back? Later on in a post I have where I added water, they grew back. Actually, I showed you guys that one. I added water, and after 10 days of no water, my experiment wasn't over. There were still fruit for me to eat. So if I was on Mars and my irrigation failed, I could fix it and then still have things to eat. And just like us as people from New Mexico, our peppers are like resilient, absolutely. Just like we are, we're always on top of it, and then we can live through it. Now, Christina Johnson, she's a NASA postdoc. So I'm not the only one from NASA who's participating in this challenge. She's the moderator. And, you know, she's just sharing that she has a little girl and they made a STEM dress. And so she shared it here. And so I frequently say that Space Chile and the Space Chile Grow Pepper Plant Challenge is one about the chili, but two, it's about the culture of the place where that chili is from, which is New Mexico. And I use this as an opportunity to share who we are and what our culture is and what we do, especially the red and green question or the ristras. We did a farolito project not too long ago. And you know, all of these things are a way for me to not only share New Mexico chili, but it also allows me to share our culture. And I'll tell you definitely that everybody in my lab and on my team at Kennedy Space Center, they know where New Mexico is. And they all are chili fans, and it's just like the coolest thing. And so we all just share our experience along the way. These are all teachers and educators, students, and different people who are growing their pepper plants. You know, Christina's growing microgreens along with her pepper plants, and she shares it. And we all post it while we document our grow outs. And the idea is that we have a good time doing research. Students like you get to learn and participate, and then you and at the same time you get some experience working with a real NASA scientist, somebody who's working in the field. And in general, I have the email jt@nasa@aol.com. You can send an email there and request your seeds. And then as you do your grow out, if you have questions, you can reach out to me, or you can put posts up on the challenge page and the community will help you. So along your way, as you make your chili challenge work, there are resources like me where you can reach out directly, or just interact with the community, and we're all here working together. This was another experience, but I don't know if anybody has heard about the Vomit Comet. But there are very few ways where you can experience microgravity on Earth. You can drop something off of a building and you'll experience weightlessness for a few seconds. There are simulators or machines where you can simulate microgravity, but you couldn't grow a plant in a few seconds in that time. Another thing that you can do is called the Vomit Comet, and it's a plane. It flies, you know, about 50,000 feet in the air, and it goes in parabolas. So it goes up, and when you're going up, you experience 2G. But then when it goes down so fast that you experience weightlessness. And what I did was built a piece of hardware that grew microgreens, and then we took it up there to the parabolic flight to test different harvesting methods. And this was the day that I did it. There's a certificate that says that Jacob is zero gravity certified. I have done things and worked on things in weightlessness, and these are New Mexico chilies that I have around it, and then my little NASA lunch bag and everything. But I just have to say that I did vomit on the Vomit Comet. I did throw up. So even though I got my job done, I still did throw up, which is pretty crazy. But I'm just going to take one more minute to go through and show something else. And then I'm going to take the rest of the time to answer some questions because I see them coming in the comment. But I went to Albuquerque, and this is Mitch. And so I met with Mitch in Albuquerque, and he's a real cool dude. He's rock and rolling there. and that's real cool. And so everybody just does their grow out, and then they share it here on the page. They record data for me along the way, and then I post my experience at NASA so everybody can participate. And bottom line is, I'm inviting all of you to join in with me. You can email me directly or go to this group page where there's an introduction and it shares everything. Also, there's a website that's coming out within the next month that'll be a NASA website, and there will be resources there, videos that I'm going to create on how to grow your plant in a pot and soil, or how to grow your plant hydroponically, what growing PHO4 is, and all that other things. And then actually one last thing, it's not all about growing plants. In New Mexico, we're very rich in art, and every NASA mission has a logo or a mission badge. And I felt like our mission badge should be drawn by local artists. So we found a local high school art students, and we asked them, we gave them some constraints, and they came up with this logo. And this is our mission badge drawn by New Mexico students. And in the end, astronaut, or she called herself Hatchstronaut, Megan MacArthur, printed it out in space. And you can find a picture of this in Google with the Earth behind it and then a pepper floating by. And so we're so proud. But it's not only about the chilies, it's also about our art and our culture and all of that. So everybody, I just invite you to join in. It doesn't matter what you do. If you're a horticulturist, if you're an engineer, if you're an artist, whatever it is, there's a place for you in the Space Chile Grow Pepper Plant Challenge. And with that, I think I'm going to stop and let's just take some questions.
So Jacob, are you able to read the chat log, or do you want me to read them to you? And I know you're on your phone, so it's a little bit difficult possibly to see them all.
Yes, please ask me them. That'd be cool.
So starting from the top, there were a few that kind of came in. There was lots of comments about how awesome it is and how everything else.
Cool.
But there was a few people interested in the challenge. So a few of our teachers. So I think you mentioned, how to get involved. Is there a deadline for the challenge, or, besides just emailing you or anything directly, like to officially sign up, or if we were to send that out? What are so the steps to officially sign up as a teacher?
The way to officially sign up as a teacher is to send an email to me at jt@nasa@aol.com. That's jtatnasa@aol.com. And just let me know that you want to participate, and I'll respond with the introduction, which gives you the lowdown or all the information about the challenge and that stuff. What makes me different from the other NASA activities is I've made it free, so or open, so you can grow your pepper plant in your own time. There isn't a deadline. If you happen to suddenly, your class has to quarantine all of a sudden, then you can give seeds to your students and let them grow them at home. But this challenge and activity is done at your own time. Make it work for you. Grow in the method that works best for you. Don't go out and buy anything. Use things that you have around. There's only 2 rules. Rule 1 is that you get the seeds from me. And then rule 2 is that you grow your pepper plant indoors or in a controlled environment. Everything else, you're free to do it in your own way. Just please document your process along the way. But no deadline.
Okay, then before we go in, I'll put that the email I have for you is a little bit different, so I'll make sure to type it in the chat, and I'll also email it out to everyone who completes the survey, and I'll get it to you, teachers. So I'll send that out to you. Some of the other questions was peppers in Antarctica. How is that possible? Did you have to send her the soil? So that was one of the questions, and you were talking about Antarctica.
Well, gosh, would you believe that I invented an irrigation system for microgravity as an intern? It was on my list of things. I have a lot of aspirations. I'm going to invent an irrigation system for space and leave it with NASA. Well, I did in the end. I got a patent for this system, and Jess took it down with her. And she grew peppers in that system using nutrient solution. Essentially, it's a hydroponic. She grew them hydroponically. Is what she did. And the nutrient solution that she used is something that we use in our lab. It's called Hoagland's nutrient solution. And you can Google that. It's a scientist who derived this chemically perfect nutrient solution in the early 1900s, and we use that a lot in our grow outs. But the mostly her grow outs were hydroponically. But on that note, we use Arcelite media in space. Arcelite is the brand name is called Turfus, and that's the red clay that you see on baseball fields sometimes. Well, essentially, we needed something that we could wash and autoclave, make sure that it's completely sterile. And then we use that as the media that the roots grow into. And then we supplement nutrients to help the plants to grow. And then I just gave her the seeds to go to Antarctica. I gave them to her.
I think that's really awesome. There was also a couple of questions about oxygen in space. There was a few comments. Since there's no oxygen in space, how does it live? And one of our teachers actually put a little comment in there, but I'd like to hear your take also on it about how they survive with no oxygen in space.
Sure. Well, we are growing in space. The International Space Station is in space, but we're growing it inside a controlled environment. The International Space Station itself is a controlled environment where it maintains the oxygen, CO2, temperature, and all of those things. And then our growth systems are little chambers or little refrigerators that maintain the temperature, humidity, oxygen, water, and all of those things. So although the International Space Station is up there in space, we're really growing inside of a container or inside of a refrigerator where the conditions are controlled and the oxygen is controlled.
And the next question is regards to temperature. It says, what if it's colder in space than where you test? What would happen then?
Yeah. Oh gosh, that's one of the coolest things about this activity is that everybody is somewhere different. I'm down in Florida where it's nice and toasty. Some of my friends are in New Mexico and Española, or even in the mountains where it's really, really cold. And so there's temperature variations between everybody. And that's where I'd like you to document your temperature as you grow. Because if you happen to grow, at 50 degrees or something, well, that's something that I would like to know, but I'm sorry that I'm having trouble with the conversions because we use Celsius. But the lowest that we've grown is 18.5 degrees Celsius in our lab and been successful with growing. And then, of course, we know our peppers, they love the heat. So we've gone up to 28 and 29 degrees C and grown our peppers. So there's a good range there. I'm sorry that I can't convert to Fahrenheit.
So there is another question is, have you thought about how you will roast the chili in space?
Oh, cool. Gosh, I made this visit to UNM before the peppers were grown, and we had a downlink with the astronauts on the space station, and one of them was Christina Cook. Her name is Christina Cook. She's so cool. And one of the students asked her that question exactly. How would you roast chili in space? And she had been to New Mexico. She's like, I've been to New Mexico. I've had green chili before. I was thinking about that. They don't have ovens on the space station, and they don't have fire because it's hard, right? Essentially, they have a microwave. And what she said was, what I would do would be to get a plastic bag and a paper towel with boiling water and wrap the chili in that boiling water for an extended period of time, and then that essentially would be the way to roast her chili. But I think it would wouldn't be really roasting, but she would probably be able to get the clear the skin off of it. But yeah, that's an open-ended question. How are we going to roast our chilies in space? There are a few ideas out there, but currently we're just eating them fresh, and that's what the crew did this time. They ate them fresh for dinner.
So there's another question. Aquaponics usually have live fish. Is that a possibility in space? I know live animals have been in space, but what about our fish friends who need to be in water to survive? Any idea?
Oh yeah, absolutely. There's Dr. Ray Wheeler. He's like our grandfather. If anybody's seen the movie The Martian, and he grows the potatoes on Mars, the potato experiment is actually Dr. Ray Wheeler, and he's a NASA scientist here who I get to work with. And one of the first things that he did was set up an aquaponics system that had a type of salmon. I don't remember exactly which type of salmon, and it was a closed loop system where they used the fertilizer or the fertilizer from they made the fish waste into a fertilizer that grew the plants, and then that waste turned into the plant waste turned into food pellets that they fed to the fish, and it was a completely closed system. And we are practicing it here on Earth, and we envision that one day a system like that will be part of the equation to meeting growing crops and being sustainable in space and in other planets.
So for everyone on the line, I did go ahead in the chat and I did paste the attendance link in the survey. So make sure that you complete that just so that I have your information to get you whatever, and also to count your attendance for today. We'll go ahead and continue to take questions, but I wanted to make a note of that. And also here, now that I'm ready to type, can you say your email again, Jacob, so I can type it a little slower in there?
Sure. JTATNASA at AOL.com.
JTATNASA at AOL.com.
Yep, that's it.
Okay.
And then now that I get funded by NASA, it may change to a NASA email, but I will always keep this one, so you guys can always reach out to me there. And I make it a point to always respond to everybody. Sometimes I get a little bit behind. Maybe I don't respond right away, but I will get back to you.
So we have a few more minutes. There was another question about if you knew anything about the black hole.
About black holes? Yes. Oh my gosh. I mean, well, I just know that black holes exist. And I don't know what's on the other side of black holes right now. I know that there's math that says that there's other things on the other side of them, but I am very fascinated with black holes myself, and I can't wait to find the one that's at the center of our galaxy.
There was another question about plants need light to grow and space can be dark. Providing light in space uses a lot of power. How can you provide light for the plants using less electricity?
Yeah. So the use of LED lighting for plant growth has been a game changer for us. Previously, we used incandescent light bulbs, fluorescent light bulbs to grow plants. And it wasn't until the 90s, and even now in the last decade, where LED lighting and technology for LEDs has really changed. And it's really not about the intensity, but more of the spectrum of lights or of light. You know, there's different colors, the colors of the rainbow. Each color is a different frequency, and each frequency does a different function for plant growth. If you supply just the necessary frequencies for your plant to grow, then the cost of providing lighting goes down a lot. But still, even with that, that's one of the biggest down points for growing crops is the lighting and the systems. There's a lot of energy that goes into it.
Thank you. So I think I've answered all the questions in the chat, unless I missed any, but I think I got them all in the chat. Is there anyone else that has a last question or so? We have about 2 more minutes. Otherwise, we are. But there's lots of great comments. I don't know, before you go, once we stop, if you can just check out, there's a lot of just thanking you for your time. This has been a really interesting, dynamic presentation. I think our teachers and our students are really excited. So thank you so much for all your time and your enthusiasm today. So we've been really excited for this presentation. Good.
That means I didn't bomb it because my computer stopped working. So that I take that very, very cool. Thank you. And just real quick, I'll share that the Hubble, the James Webb telescope launched recently, and they started their own group page, and it's a lot like the Space Chile Challenge group page. So there are other NASA groups who are doing things that we're doing too, and you can link up with them on the Space Chile Challenge page as well.
Okay, well, thank you so much for your presentation. I'm going to go ahead and stop our recording now.